Hello the internet and welcome back to Tony259, Tony359's second channel. Today on the bench we have a Rane RPM88. It's a programmable multiprocessor. It's an audio device. It's a massive DSP, 10 channel inputs, 10 channel output, and it's just a massively flexible DSP for a sound system. This is my own device. It's been living in my home theater for a few years and I absolutely love it, and today I'd like to tweak it a bit. In a sound system you might need a crossover, an equalizer, a high-pass filter. You might need to tweak the level of the channel, and back in the days you would buy one device per function. So you would buy the crossover, you would buy the equalizer and that kind of stuff. And then over time, when digital stuff came out, you could buy like flexible devices where you have a number of input, a number of outputs, and you can enable and disable the crossover, the high-pass filters, the equalizers, the feedback destroyer, and all those kind of features. Now, this is a similar unit, but it's like the next level of flexibility. You have 10 inputs, 10 outputs, and you literally have a graphic interface in the middle. You can create your own project, like dragging and dropping components. Like you need an equalizer. Yes, sure, just drag it and drop it in the middle, and you connect it to input number 1. It runs through the equalizer, and then it goes to output number 7. Whatever. You want to add something else, you just break the graphical link and you add another component, a high-pass filter. You want it before the equalizer, you want it after the equalizer. The sky is the limit, and I really love this thing. It's so flexible, and if you want to buy something similar nowadays, it's not cheap. I think this unit back in 2006 was retailed for more than $3,000. I got this mostly almost for free from my previous employer that was just getting rid of it. So I don't want to break it, and I want to make it a bit more reliable today. Now, this unit has been long discontinued, but it's still working. There's a software that still runs under Windows. It works totally fine. If you're interested to see, later on I'll give you like a guided tour of the unit. I'll show you my own project I'm using in my home theater for my sound system. Now, this unit works totally fine. So why is it on my desk today? Well, the reason for this unit to be on my desk today is this. That's the reason, the fan. Now, when I got this unit, it was horribly noisy. This is a unit that will end up in a soundtrack, in a cinema, in a venue, in somewhere where noise is not a concern. There will be lots of amplifiers and equipment. It's going to be like an equipment room, very noisy, where keeping the equipment as cool as possible is the priority. The noise is not the problem. This is not a hi-fi device. It's not going to be used in a living room, but I'm actually using it in a living room. Well, actually, I have a small home theater, and when I got this thing, it had one of those hideous fans, running a very high RPM, very noisy, and I replaced it with a quieter one, but I believe this is like a 30mm fan, so options are not many when it comes to such smaller fans. But, it works. It's pretty quiet now. But some time ago, I did a similar thing with my NAS. I think I mentioned that on another video, my Netgear NAS. I replaced the power supply fan with a Noctua, those magical Noctua fan that resolve all the noise problem without thinking too much of the airflow. Now, I'm not using this too much. I'm using this for 2-3 hours, then I turn it off. And actually, I'm using my NAS all the time. It's 24/7. Now, the NAS almost exploded because the power supply badly failed because all the capacitors exploded. Basically, well, they swell up, so I had to replace all the capacitors. Now, I'd hate to lose this unit. As I said, it was pretty expensive, and buying a similar device nowadays is not cheap. It's not something that you can buy for cheap. If it is for cheap, it's probably not going to be the same quality that this has. So today, number one, I want to make sure I haven't caused any damage to the power supply, which is on this side of the unit. Number two, I might want to open up a hole here, because you can see they're very, very small holes, and that just doesn't work with the fan. I'm sure it's done on purpose for electromagnetic interference. Also, it's a sound device, so you don't want to have big gaps where interferences might come in. You might have a big amplifier sitting on top or wires going around. So it's a unit. It's a professional unit. It has to be designed with that in mind. but I'm using it for myself. I'd rather have it more reliable than, baking it to death and then it's unfixable and then I have to throw it away. So we'll open it up, we'll take a look at what we have, but I have a feeling what I'm going to do, I'm going to use my Dremel or something and just open a big hole here. At that point, I'm sure the existing fan will just triple the airflow, because again, as it is right now, there's really not much coming out of it. Actually, let me test it straight away, because it's been a long time. So the fan is actually not too bad. I mean, I can feel air coming out, which is surprising. But whenever this is being used, I can feel it gets really hot. So I want to remove the fan and, try to get an idea of how much airflow I'm missing, I'm losing because of this metal plate in front of it. And then I'll decide whether I want to, just enlarge this hole and then I'll put a grill on top to make it nice and call it a day. So let's open up the unit so we can take a look together and take out the fan and test it and see how it works in free air. The unit is very professionally made, and I never felt brave enough to just dig inside this unit. I really don't want to break it, because as I said, it wouldn't be easy to just replace it. But what you see here on top, that's the analog board with the inputs and outputs. I think these are the outputs and these are the inputs. And very nicely here on the right hand side, the power supply is completely disconnected. So anything happens to the power supply, hopefully, finger crossed, it's a separate unit that can be replaced. We got mains coming in, and then we got something coming out, which goes to a board at the bottom, which has further power supply things happening. But the main power supply is here on this board. One of the reasons I don't want to overheat this unit, besides general reliability, is that, as you can see, there's quite a few capacitors here, and I don't want to damage them in any ways, because eventually these capacitors, if they are heated up too much, they will just start failing, and then you start having all sort of trouble on your audio output. So let's see if we can improve on that ventilation. Now, the fan has an interesting installation. Now, the wiring is mine from many years ago, but that paper spacer that is in front between the fan and the chassis is actually from factory, and it works pretty well. Because if you install that fan straight attached to the metal frame, and the metal frame only has a few small holes, the fan won't do anything. This way, the airflow is actually improved quite a lot. But what I'd like to try now is let's remove the fan and try and compare the airflow with and without the metal frame in the middle. Now, this is probably overkill, but I happen to have an anemometer, which is measuring the air speed. So let's try and measure the speed of the air coming out of the unit with the fan in place as it is right now, and then we'll take it out and we'll measure without the metal frame in between. Well, the propeller inside my tool here is not even spinning. The fan doesn't have enough power. That being said, this is a bit too big and I have the mains cable in the way, so I can't just seal the area appropriately. But, let's just keep that in mind. We'll do a comparison. It's probably like a completely useless test, but, I have it. I didn't buy it for this. So let's take the fan out. And again, I'll also do like a manual subjective verification comparison between as it is now and as it is outside of the case. Alright, if I remember right, I think I installed some either resistors or probably more likely diodes in series with the fan to slow it down and reduce the noise even further. Ideally, I'd like to remove all of that, but first thing first, let's compare the speed of the fan, the airflow actually of the fan, without the metal frame in the way. And actually, I don't think there's a huge difference. I just feel, this is probably, I would say, an inadequate fan. So maybe first thing first, I want to, first of all, maybe speed it up a bit. Secondly, I think I might want to find a replacement. I'm not thinking of a Noctua, but unfortunately when it comes to 30 by 30, there's not much available. But maybe something which is not 10 millimeters, something a bit longer. Last time I tried to reuse what I had. This time I'd like to, find a better solution. So a better fan, and maybe then use some noise reduction, how would you call those things that you attach to a metal frame, and see if I can get more airflow, because this is really nothing. It's like breathing. There's not much coming out of it. I'm sure the instrument here is still not moving. It is actually moving. So yeah, there is a difference, because now the instrument is moving. Yeah. Let me see what I can find, and then we'll come up with something a bit more permanent. This is a 5 volts fan, but some units sometimes they actually output a lower voltage to keep the noise down. So let me just double check and confirm the actual voltage coming out of the unit. Yeah, we have 5 volts, so I can definitely check that one. And I was using for my fan, just out of curiosity, 2.9, so I actually slowed it down quite a lot. But I think I might have seen something online which I might want to try. The replacement fan has arrived, and yes, it is a Noctua. It's the NF-A4X2O 5 volts version. So this is a 40 by 20 millimeters. So this is going to be a bit deeper than my existing fan. And yes, I do know that Noctuas are a bit overpriced, overrated, over everything. But I went through the specifications, assuming they are actually accurate. And this is a Delta fan. The Delta fan is rated 4,000 RPMs. This is 5,000 RPMs. Now, when it comes to RPMs, more RPMs means louder, so that's not necessarily a good thing. The Delta is rated for 7.44 cubic meter per hour. The Noctua is rated 9.4 cubic meter per hour, so it's a little bit more airflow, and I'm gonna slow them down anyway, so the more the better. When it comes to pressure, because these values are only valid in free air, the Delta is 1.7 millimeter of water, and this is 2.26 millimeter of water. So this is a bit more powerful in terms of pushing through something. Now, I'm gonna have this grill at the back. I'm gonna make a hole at the back of that unit, so that really shouldn't do anything. But I would say it's nice to have a little bit more pressure, because this is literally like in free air with no resistance whatsoever. So it's nice to have a little bit more power when it comes to that. Now, let's see the noise of this fan. So I'll try and translate this through the microphone. Yes, I'd appreciate it's not much difference. Actually, I don't know whether the Noctua is actually a bit noisier. I don't know. Let's try and measure the airflow. And I completely appreciate that with this tool here, I can't really have an exact measurement, because this should be go entirely sealed. It should be sealed with the fan, basically. I should have a smaller one or some sort of an adapter. But I'm gonna try this anyways, and we'll see what happens. I mean, because the test is flowed, but it's consistent between the two fans, it should provide some sort of comparable results. Let's see what we get. By the way, I'm running at 5 volts, so this is full speed. We get 1.8588 meter per second with this fan, and about 2.3 with the Noctua. So yes, there is an improvement. I don't mind it, and then we'll see when it's in the unit, you know, how much noise it makes. Obviously, my home theater is pretty quiet. I don't want to have this noise in the background. I might need to tweak it over time, but as long as I have a bit more airflow than I had before, I think it might help. Now, the next step is to make a hole behind that unit, and I'll take all possible precautions, because I don't want metal shards or anything to go anywhere. So I'll try and seal it and try not to damage anything. Okay. All right, almost there. I hate these brown silicon things. Noctua, you need to revise that thing. Now I'm going to remove these terminal block because whenever you screw something in it, and if you need to remove it for whatever reason, you have to redo all the wiring, especially these little ferrules that I like to use. Not sure how well you can see them. So I'm gonna use Wago, whatever you want to call them. I like them because they can be, installed and uninstalled at ease. Should work. They definitely work with higher voltages. I've been using them with fans for a while. Now, this expensive fan doesn't come with, I think it's called like the low noise and ultra low noise adapters, which is basically just a resistor. So I'll have to make my own. That's interesting. That being said, so first we're going to test it with just 5 volts to see how it goes. That being said, this is what was inside the adapter that I made, and it's not too bad. It's just 3 diodes in series. So each diode should be 0.7. So this is like 2.1 volts voltage drop, regardless of the resistance that you have on the other side. Sometimes I use diodes when I need a certain amount of voltage drop, so you don't have to do calculations, and it's not too bad actually. It's not badly made. It just needs a little bit of heat shrink, bigger one on top. I didn't have it probably last time, but I do have it now, so we can actually use this one, or maybe only 2. I'll see. Let's begin with 5 volts as it is, and we'll see how it goes. That's not touching anything, so you can stay there for a moment. I'll do a test here and decide whether I want to turn it up, down, or leave it as it is. Now, before you ask, I know that you can install a little variable buck converter and change the voltage there. Let me show you. Something like this would be ideal because it has a trimmer and you can choose the voltage. Now, this is an audio device, and this is introducing noise everywhere. Even the fan itself, to be honest, is introducing noise. So I'm assuming that this device has appropriate filtering where the power for the fan is going. What I don't want to do, I don't want to introduce any more noise, because I've actually have experience myself of installing a fan in a sound device, and you ended up with the fan noise at the outputs, because just the magnetic field inside the rotor would get into the audio output. So, I don't want to get onto this. This is easier, but I don't want to use it now. This is switching, it's making all sort of interference and sort of noises that might end up on the analog output. So for now, this is it, and we'll just test it as it is. And by the way, I'm giving up with trying to fit these brown thingies into my little grill in here. I just can't do it. So if someone knows how to do that, I know that I used like pliers in the past to just grab them, and I broke them every time. So I don't want to do it this time. Fair enough, it's not going anywhere, but I don't understand why this one went all in, but this didn't. And I also forgotten to paint it black a little bit. Maybe I can do that at some point. I completely forgot. But it's not too bad. I mean, I'm happy with the outcome there. Okay, let's power this up. 3, 2, 1, go. I would say that this is way too noisy. Yeah, it's difficult to translate in here, but I have like 100 times the airflow that I had before. So I would say this is good. We can lower the voltage a bit and hope it's okay. I got my little contraption that should take down the voltage to about, I think we saw 2.9 volts. So let's power up, see how it runs at 2.9. 3, 2, 1, go. I think I have it the other way around, probably. I hope so. I think it's not bad. I think I'd like to remove one diode, so we only have 1.4 voltage drop. We are at 3.6 volts, and I think I like it. I think I'll test it. Again, I need to test it in my home theater. I think it's okay, and I feel it's quite an upgrade to what it was before. So let me just finish this bit here, close everything, and then I'll show you how this thing works, because it's quite interesting. Stay with me. Now, I really want to install this grill, so I thought I would just make these holes a bit, these hooks, whatever you want to call them, a bit bigger. I should be able to just, just make them a bit larger with my screwdriver. That might help a bit. I have a few more. It came with a pack of 4, like you need 4 fans, 4 40mm fans in your life. I'm gonna open a hole in my finger here. E questo sta così, via, non c'è nulla a fare. Now I cannot run exactly the same test because of these silicon bits here, but let's see if my anemometer is reading something. Remember that at the beginning it wasn't reading absolutely anything. And I would say there is quite a difference compared to what it was before. And again, I'm not even close to the chassis. So yes, the upgrade is definitely successful. All right, we have a little plot twist. So I'm shooting this after I thought I finished the video. And I took this back to my home theater, I wired it up, I turned everything on, and I could hear the fan in the speakers. Very faint, it's very faint noise, but I was like, I can't remember hearing that before, but I had a fan, so how is that even possible? And I thought, I don't care, I'll just leave it, and then no, I just can't, you know, all this work and everything, and then now I'm hearing the fan. So, the Rane is back on the bench, and I've got my Focusrite here, which I fixed in another episode of my main channel, so go and have a look, it's a very popular video, it's a nice repair. And I made a little lead here that basically allows me to connect the output, one of the outputs of the Rane into my Focusrite, because what I want to do is I want to see this noise. I want to see it so I can try and find out where it's coming from. So the options here are 2 options. The first one, let's say 3 options. The first one is the fan itself, the rotor itself, is making some magnetic interference, which is getting into the analog section. And unfortunately, you know, the analog section is just here. That's an option. If that's the case, I can't fix it. It means I have to replace the fan. It means the other fan, the one that was there before, was less potent. I don't know. It was making less interference. The second option is, now I've been tinkering here a little bit, but I had the power cable for the fan going this way. Maybe this is enough to get some interference on the analog board, and I should just tuck it away. That's a possibility. The third option, and I hope that's the one that belongs that applies to this device, is that the fan is making some switching noise, just the way the motor works, and that goes back to the power supply, which eventually goes back to the whole board. Now, the digital section is unaffected by those things, but the analog section, if the supply voltage is dirty, then you have noise at the output, right? And this is something I've dealt before with, so I should know how to fix it. So, but the first thing I need to do, I need to see this. I need to be able to see this noise. So what I got, again, I said I got the Focusrite. I'm gonna plug this into my Focusrite. It's gonna be channel 3, because I think it's the one connected to my right channel in my home theater. That's where I could hear it most, maybe. And on screen now, you should see a software called Smart. Smart is a spectrum analyzer. So what you see on screen is the visual representation of the audible spectrum from 20 Hz on the left to 20 kHz on the right. Now, this is with no output, so it's very, very faint. I mean, this is, if I put some pink noise on it or any noise, it would be much higher. But you see, it's kind of, you have a little bit of interference, you have a little bit of peaks. Now, let me stop the fan and see if something happens there. I'm expecting to see some difference. So I'll stop the fan with my finger. There you go. You see that there's an area around, I don't know, what frequency is that? Let's check that frequency here. Around 500 Hertz. Let's turn it on again. Yes, it's in here, and I think this is the main frequency, or maybe this one. So it's around 535 Hertz, and I think these are harmonics of that frequency. But if you look at this frequency here, when I'm stopping the fan, this goes away, and also these are going away. It's not much, because again, that's the noise floor. It's very, very low, but I could hear it a little bit. Now, is this coming from the fan, from the cable, from the wiring, or is it like just noise going through the supply voltage back into the analog section? So first thing first, let's try and move these wires away. And no, I don't see any difference. I mean, I can't do any better than that. So I think if I stop it again, yes, those frequencies are disappearing again. Yes. The next step to find out whether the noise is coming from the fan itself or is going back to the supply voltage, I'm going to unplug the fan here. So you will see the spectrum analyzer is getting quieter again. Ish. It's quite some noise, I'm not sure. I mean, it's okay to have some noise, of course, at the when you're looking at some noise floor of any device. What I'm going to do, I have here my bench power supply. I'm going to power the fan externally with about 3 volts. I think that's what we were supplying after those 2 diodes. And see whether the noise is coming back or not. So 3, 2, 1, go. Yes. Fan is spinning, but I don't see that frequency at 500, and what's that, 535, something like that. It was around here. There's nothing. Most importantly, if I stop it now, there's no difference. That's bouncing up and down, but there is no difference. Starting again now, and there's no difference. That is great news. It means it's not an electromagnetic interference, it's actually noise going back to the supply into the analog port. And I think I know how to fix that. I'm going to use one of these. It's actually my design. I mean, it's not a design. It's a simple PCB. It's an RC filter, resistor and capacitor. So I have a resistor in here and the capacitor, and this is going to filter out all the high frequencies. This is basically letting only very low frequencies, and DC is the lowest frequencies that you can get because there's no frequency. It's like 0 Hertz. Okay, so I don't know, I think at some point I had to deal with a similar issue for a different device, and I came up with this. It has a 1000 microfarad capacitor, and the resistance is gonna depend on the voltage I'm getting at the fan now. So I'll have to experiment a little bit, but I need the resistor here. I can't just do with the diodes. So the capacitor is going on the other side. I can solder this together, and that should filter out that noise. At least it works for something else I'm doing. So let me assemble this, find the resistor that works, that basically ends up getting the same voltage that we're getting now with 2 diodes, and then hopefully we won't have the noise anymore. Okay, well, the filter is assembled and installed. Got one resistor here, which is taking the voltage to, I think it's 3.3 volts. It was like 3.6 before, so, it should be fine. And we got the capacitor on the other side with the right polarity. This is a 1000 microfarad, and it's rated 25 volts, so it's plenty. Resistor, I think it's a 30 ohm. I did a little experimentation, and that's what worked. So we can... I'll put some heat shrink, of course, now, but we can do a quick test first and make sure it works. All right, let's power up the Rane. 3, 2, 1, go. Okie dokie. And I have removed the power supply from my laptop. It's now running on battery. And obviously it is so much cleaner than before. The fan is actually spinning. Now, I'm sorry I didn't think about that. All that noise, it was the power supply. But you could definitely see the fan right now at 500 and something, which is here. There's really nothing. The fan is spinning and is connected to the actual machine. And if I stop the fan, nothing changes. Absolutely nothing changes. So this is absolutely working. I'm sorry I didn't think about the power supply earlier on. I could see all that noise. I don't know, I didn't think about that. Power supplies on laptops, they always introduce noise, which eventually reach your sound card, your sound, everything. But when you're on battery, obviously, that doesn't happen. But this is amazing. I think I fixed the problem. Let me put some heat shrink, tidy up the wires, and then I guess I can continue with the outro that I did before. Alright, all done. I'll close it, put it back in my home theater, and hopefully this time I won't hear the fan. So back to me a couple of hours ago. Alright, let me quickly show you how this device works. It's really amazing. Now, this is a blank project. Bear in mind, this is a discontinued device. The software is very old. It still works. This is Windows 11, so it's great. And this is a blank project. So this is offline. I'm just making it, and then this can be uploaded to the DSP. Now on the left hand side you have all your inputs from 1 to 8, plus you have 2 digital inputs, A and B. On the right hand side you have the analog outputs from 1 to 8, digital B. These are the inputs and outputs of the machine. Now let's say you want to connect input 1 to output 1 without doing anything. That's it. It's connected. Say that you want a parametric equalizer instead on input 1, and then the output of the equalizer go to output 1. That's it, it's done. And say you want the output of the equalizer on both output 1 and output 2. That's it, it's done. This say you want, I don't know, a delay just before the parametric equalizer here. Once again, it's just a matter of joining lines here. Now, this is the inside of your parametric equalizer, and obviously you can have up to add filter. There it is. Can't remember that there is a limit. Is there? Yes, 15 filters, and the limit of this machine is the processing power itself. Now, as you can imagine, you have these DSPs on these machines, and they will be at some point, once you compile or load this thing, we can check in a minute, there will be an indication of how much leftover power there is in the machine. At some point on my own design for my home theater, I've reached the maximum. I just can't add anything else because the machine will complain that there's no enough processing power for that. So as you can see, this is just amazing. It's just, you can do whatever you want. I like sound a bit, and when I was doing my sound system setup and everything, again, if I wanted a high-pass filter, change an equalizer, add the limiter, add a compressor, add a delay, a selector, I could do that. And obviously, you can have different projects, or well, you have one project with different settings. You have a number of presets here. You have 24 presets. So say, for example, one preset has one set of equalizer, the other preset has a different set of equalizer. The project is the same, but if you want to mute one channel on one preset or have a higher level on another channel with the other preset, that can be done at a click of a button. And obviously these things can be driven by serial, probably even by Ethernet. Again, it's an old lady here, but it's designed to communicate with other things. So the idea is just to push a button and it changes your preset. Now the Rane here is connected and it's on the network. So in theory, I should be able to see here. If I say look on Ethernet, there it is, 192.168.0.220, and if I double click on it, I'm actually going on a live display of the project which is loaded on the machine. Can be on the slow side. I have a feeling this software is not designed for Windows 11, or anyway, it's an old software. And this is the design of my home theater. I don't want to go through everything. And to be honest, I haven't looked into that for a long time. I can't remember why I have a mixer here. But yeah, my home theater has, well, it's a 5.1 home theater. I have a shaker on my seat. So there it is. There should be a shaker output here, which is going outside of the screen. There it is. It's going to the shaker output. And there is a limiter for the shaker. I realized it's kind of low power, so I thought a limiter was the best thing. And it's getting the signal from the subwoofer output, and there is a high-pass filter on the shaker, because I realized the shaker doesn't really like more than, I've got 40 hertz. I don't use it over 40 hertz. It's make vibrations, which, I don't know, I have subwoofers for that. And this is only literally shaking the chair. And I could do that. I have a high-pass filter, so the shakers only get from 40 hertz downwards, from 40 hertz below. How do you say that? And then you have a level setting, and you have a limiter, which I think I'm, just to make sure they don't blow up. These are my stage channels. They are bi-amped, but they are active speakers. They're JBL active speakers. So I don't really need a crossover into this thing. But what I've done, I'm on one of the presets, I'm actually sending the very low frequencies to the subwoofer. So this is actually set to 40 hertz. So the speaker is getting from 40 hertz to 20K. And the rest is going into this mixer, which is going into the subwoofer. So the subwoofer is getting all the low frequencies from all the channels, plus the subwoofer, the actual subwoofer signal. Oh, and this matrix mixer is, well, it's there for diagnostic purposes. It's nice sometimes to be able to mute one channel from here. Obviously, I can send one channel to another channel if I want to do a comparison of something, an EQ comparison or whatever, just for fun. And also, obviously, I got the subwoofer signal, which I think is going on both the subwoofer and the shaker output. It's the same output, but it comes with a different equalization and presets and that kind of stuff. You can do absolutely anything, and the sky is really the limit. That's why I really like this machine. I didn't want to break it because it's overheating, and I think we've done a lot. And obviously I'll keep an eye on this machine. I'll keep it running for a while, probably here in the lab, so I can check what's the, if it feels hot or whether we actually improved it a bit. There is also a signal generator within the design. It's in here, and that's another reason I had the matrix. This is normally muted, and if I open the matrix, the signal generator is going on input 10 here. If I mute it, you can see that input 10 has signal, it's green, and I can click, I don't know, here, for example. Now I have input 10 routed through output 1, as long as input 1, which is going to output 1. That's my left channel. But now my left channel, if I had something connected, I would also have my pink noise set to -40. So again, I love this thing. It's completely flexible. A modern equivalent of these is manufactured by QSC. It's called QSys. I used to work with those things. It's absolutely amazing. It has a million options. So the good thing is you can do whatever you want. The bad thing is you have to learn it. So if you're not too familiar with that, or you are not too familiar with sound systems in general, it's so very easy to make a mistake. But once you know your stuff, it's just incredibly flexible. It's just the newer generation of this. I'd be surprised if this is they are somehow linked from a company or product perspective. I don't know, because this looks really, really similar. Let me disable my pink noise, so I don't want to have pink noise next time I turn this on. And I guess this is it. So this is working fine. I'll take a look over the next few days whether the modification has helped a bit. I'm sure, without that grill, that useless small holes at the back, I'm sure this is going to be so much better, regardless of the type of fan. The fan should have a little bit more airflow, but between the fan and the hole at the back, it should be so much better now. Please do let me know, how can I fit those silicone things around my grill? It doesn't go anywhere, so I don't really care, but it doesn't look right. Let me think what you think about this device. Are you into sound? Do you like the Rane brand? Do you like this kind of devices, or would you rather have, the old-fashioned, I want one box for the equalizer, one box for the crossover, one box for the limiter, so you can have maybe more control? I don't know. It's maybe you have one knob for everything, for one purpose, rather than one knob doing lots and lots of stuff. Let me know what you think about this software and about this video. What can I say? Thanks to all my patrons for helping the channel. Thanks for watching. Like the channel, subscribe if you think you like this thing, and I guess I'll see you on my next video here on my second channel. Remember, this is the second channel of Tony359, so take a look at Tony359's videos if you like this kind of things, and let me know what you think about everything. For now, thank you very much. Have a good day. See you next time. Bye bye.